Dear class, in continuation to my previous videos, today I'll continue with the programming of 8085 microprocessor using stack and memory interfacing. Okay. I'll take, I think this time it will be P5 to add two 8-bit numbers. Okay, this is your aim today. Okay, using stack and memory interfacing. So what happened is, actually this program is generally very useful for your competitive service, competitive exams. So your memory goes something like this, and taking that this is the top of the memory, H, and this is the bottom part of your memory. It starts from 000 with 16-bit address lines. And what happened is, when you're using a stack, I'll write ... because there's a lot of memory. I'll use a portion of the memory location for stack. At the same time, I'll use a portion of the memory location to store my input, output, and results. Okay, so let's say that this is F075, this is F074, this is F073, this is F072, ... and this will be F050, F051, F052, F053, H. Okay, so just like in the previous example, this is I'll store my first data here, I'll store my second, no, sorry, let's take another number. Let's take another number, 99H and 88H. Okay, so here I'll store my result, whatever accumulator data, I'll store it here, and here I'll store my flag data, my flag register status. Okay, so how do I get this first data into the microprocessor? I'll do similarly like in the previous program. I'll do LX by F0. I'll initialize this as top of my stack, F075. So what happened is, here is the top of a stack, that SP, which is that SP register, which is 16-bit register. I told you that in the first class itself, F075. It will be loaded this way. Okay, after this line. Now next is, I'll try to get the first data from the memory. So I'll do the typical like I've done in the previous class. So I'll move whatever is there in the memory into the accumulator. Then I'll increment my edge. It'll point to F051 now. Then I'll add M. This is, I've borrowed it from the previous lectures. Now what happened? Now next, add M. So now, as I told you from the previous class, that the results is there in accumulator now. Okay, so what I'll do now is, I'll do push PSW. Okay, push PSW means push program status word. When I do push program status word means, I told you already that PSW is consists of accumulator content and flag content. So when you do push PSW means you're trying to push this accumulator content and flag into your stack. So what happened here is this is the top of your stack because you've initialized your stack pointer with F075. So this is the top of your stack. The first location will not be filled with anything. Okay. Next location is going to be filled with accumulator content and flag content. Okay, the next one. So after this line, when you do PSW, your pointer will point here now, not here anymore. Okay, now this thing, push accumulator. After this, you popped it into a register, say a DE register. Okay, when I do pop means which means after the end of this line, your DE register will contain accumulator and will contain flag content. Now I wanted to put this data into my F052 and F053. So what I'll do is, because I'll increment my edge, because the previous increment was here, this is F050. If I increment here, it becomes F051. So if I increment here again, it becomes my HL pair will become F0. F051 will become F052. Okay, then I'll move, because I want in F052 I want my accumulator. So what accumulator means, it's there in D register. So whatever is in D register, I'll move into M. Whatever is in D register, I'm moving it into a memory location. Which memory location? F052. Okay, now again I'll increment because I wanted to get my flag. My flag I wanted to put in F053. So this is F052. Here HL will become F053. Then I'll move my flag. My flag according to my pop is, my flag is there in E register. So whatever is there in E register is going to move to M. Now I'm done. Okay, so my accumulator content and flag content is there. So now I'll halt the program. Okay, so what actually you're trying to see here is when you're trying to, what I mean to say here, when you're trying to use PSW register here, you can use it only using pushed and pop instruction. You cannot, there's no other instruction which is available for your accumulator and flag. So for that I need a stack. That's why I initialize SP, so that I can use pushed and pop to accommodate, to be able to read the accumulator and flag content, especially for the flag content. Accumulator you can do it otherwise also, and as in previous videos, but especially the flag content, the only way for you to do it is to use this register PSW, that is using push and pop instruction. And this push and pop instruction is only related with stack pointer. So if you're using push and pop, you have to use SP register. Okay, so what happened here is, so what will be my results? Okay, and question will be, what will be my results? So my two data, F050 and F051 is my first data and second data, and I've taken 99. 99 is 99H plus 88H. Okay, this will be depicted as 1001, 1001, and my this thing is 8 is 1000, 1000. Keep this in mind. This will be 1 0 0, and 1 and 1 is 0 with a carry 1. 1 and 1 becomes 0, then it becomes 1 and becomes 0, then it becomes 0 with a carry 1. Okay, so the results to this is 2 and this is 1. So the result is 2 and 1 H with the carry 1. Now, which means what happened is, in your accumulator you will get 21 H. Okay, similarly here also, instead of accumulator content will be 21 H. Okay, now what will be there in your flag register? Okay, now your flag register takes a form of okay, this is as Z A B C. I should remember it as ZAP C. Okay, so I will never forget it ever in my life. So what happened is, according to this operation, by the way, here it's unused. Okay, generally they fill them with zeros. So in this operation, when you're adding, there is a carry. A carry. Is there a carry? Yes, there's a carry. So this will be 1. When it's unused, you put 0. Parity. When even parity is there, when odd parity is 0. So here there are two number of ones in your results. In your result, this is your result. In your result, there are two number of ones. So it's even parity. So it's 1. Again 0. Auxiliary carry. Auxiliary carry is, if there's a carry, this is your auxiliary carry. When there's a carry from your lower operation, lower forbid operation, lower nibble to your higher nibble. When there's a carry from the lower operation, from the lower nibble to the higher nibble, this is called an auxiliary carry. So there is an auxiliary carry, so I put 1 in not use 0. When here is 0, is your answer 0? It's not 0, so it has to be 0. If your answer is 0, means your condition is true, so it is 1. And sign operation means, sign operation is this bit. If it is 0, it is positive. If it is 1, it is negative. Okay, so here 0 means it's a positive number, so you put 0 here. Okay, so this is interpreted as this is 1, this is 5. Okay, so this, your flag register will actually contain 5H. So this is your flag register 15H, and this is also 15H. Okay, so that's it for this type of programming. In case you have any doubts, kindly write in the comment section, or you can ping me in Google Classroom. I will answer them. So kindly subscribe to the channel for further updates. Thank you for now.